Hi everyone, I am Dr. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. Today we are going to see this subject electron devices and circuits. The topic is Astable Multivibrator. After watching this video, students can understand the concept of the Astable Multivibrator. Introduction. A multivibrator is an electronic circuit that is used to implement two-state systems like oscillator, timers and flip-flops. It is characterized by two amplifying devices cross-coupled by the resistor or capacitors. Invention. Henry Abraham and Eugene Bloch described the first multivibrator circuit in 1920, also called a plate-coupled multivibrator. It was made from vacuum tubes and its harmonics are being used to calibrate a wave meter. Classification of multivibrator. There are three types. One is astable, second one is monostable and third one is bistable. Astable means there is no stable state and monostable means only one stable state and bistable means there are two stable states. A multivibrator that generates the square wave without using the external triggering pulse is known as astable multivibrator. It also known as free running multivibrator. Without any pulse, we are making the square wave. That is called astable multivibrator. This is a circuit diagram of the astable multivibrator. Here there are two transistors Q1 and Q2. These two transistors are identical. That is, when the Q1 is on, the Q2 automatically will be off. When the Q2 is on, the Q1 will be off. And R1, R2 are the voltage divider circuit and C1, C2 are the capacitors. This circuit consists of two transistors, a cross-coupled feedback network, two capacitors and four resistors. Consider Q1 is on and Q2 is off. In this situation, VCC drops across RL. Hence, VC1 equal to 0, VC2 equal to VCC. Now, C1 discharging and C2 charging. When VCC is applied, one transistor will start conducting slightly more than the other transistor. Next, considering Q2 is on and Q1 is off. VCC drops across RL2, hence VC2 equal to 0 and point B is at the ground potential and VC1 equal to VCC. C2 is discharging and C1 is charging. So this is the waveform of the astable multivibrator. When the Q1 is off, the voltage at the output will be VCC. When Q1 is on, the voltage at the transistor Q1 is 0. Like that, when Q2 is on, voltage in the collector will be 0 and Q2 is off. In this time, the voltage at the Q2 transistor will be VCC. T1 indicates time period of the Q1 off and T2 indicates time period for the Q1 on. Total time period T equal to T1 plus T2. So let us see the frequency of oscillation. It can be provided off time of Q1 is T1 equal to 0.69 R1 C1 and Q2 is T2 equal to 0.69 R2 C2. So consider T equal to T1 plus T2. So 0 into 69 R1 C1 plus R2 C2. If R equal to R1 equal to R2 equal to R and C equal to C2 equal to C, then total time period T equal to 1.38 RC. So F equal to 1 by T, so you will get 1 by 1.38 RC, that is equal to 0.7 by RC. Application is used in the application where the low clock frequency clock pulse strain is required. Timing signals, relaxation oscillators. Thank you.